The equipment we need for this episode is a heat-resistant beaker or glass,
some balloons,
some boiling water,
and a fridge or freezer to cool our balloons in. In this experiment, we're going to be using boiling water, so for safety reasons, we highly recommend the use of goggles, temperature-resistant gloves, and an apron or lab coat to protect from spills and splashes. The first step in our experiment is going to be to blow up our balloon. Now, if you watched our previous episode, we're going to want to blow it up a little bit more this time. Like so. We're just going to tie it off like so. There you go.
The next step in our experiment is to pour boiling water into our glass beaker. Place your balloon into the beaker. In our first attempt at this experiment, we used a water balloon in boiling water. As the water balloon sits on top of the boiling water, it gradually increases in size. There's only one problem with a water balloon. They tend to pop because of their small size. In our second attempt, we used a full-size 12-inch party balloon and less water. We also placed a lid on the top to contain the hot air inside the beaker. In this version of our experiment, we see a more dramatic change in the balloon's size, as well as a much lower risk of the balloon popping. For the second portion of our experiment, we're going to place a balloon into the freezer. Leave your balloon in the freezer for a few hours. After a couple of hours, when we remove our balloon from the freezer, we'll notice it's smaller in size. As it warms up, it will gradually increase in size. In our experiment, our balloon is filled with gaseous air molecules. When the balloon is placed in the beaker with boiling water, the energy from the higher temperature water and steam molecules transfer to the lower temperature air molecules inside our balloon, exciting them. When the air molecules in our balloon are excited, by raising their temperature, they spread further and further apart, increasing the volume of space they take up. The higher the temperature, or the more energy the air molecules get, the larger our balloon will grow, or in other words, the greater the volume of space our gas will take up. If we remove our balloon from the hot water, the air molecules inside our balloon will gradually lose the energy they've been given, dropping back to room temperature, causing the balloon to shrink in volume back to its original size. In the second portion of our experiment, we place our balloon in a freezer, which causes a transfer of energy in the form of heat from the warmer air molecules inside our balloon into the cold freezer. As the energy is removed from our air molecules, they slow down, drop in temperature, and get closer and closer together, decreasing the volume of space they take up. The colder the air molecules get, the closer together they will be. If the temperature of a gas is lowered low enough, it will go through a change in state from a gas into a liquid. When we remove our balloon from the freezer, the air molecules inside will gradually gain extra energy from the air in the environment, raising its temperature, causing the balloon to increase in volume back to its original size. By changing the temperature of our balloon, we can clearly see the directly proportional relationship between the temperature and volume of an ideal gas,